Thanks for the invitation. Today I'll talk about the story of an AI-driven team, the story of Innoplexus. A lot of times, and some of you who have heard me before, I have talked about this. A lot of times when we are in a university, when we are in academia, we love wicked problems. We want to solve tough problems, and that's what gives us the kick. You know, solving something that nobody has solved. Our story is slightly different because it starts with the why. Why did we want to solve a problem? And I start with a Sanskrit phrase, a verse that says, Tamsoma Jyotirgamay, from darkness towards light. When I came to Germany, one of my first bosses, a very dear friend and a mentor, called me at 2 in the morning. Typically, the calls used to happen at 1 or 2 in the morning because as I was crazy, he is still crazy, sleeping 3 or 4 hours and working really hard. So I got this call at 2 in the morning, and he told me, today I have a bad news to share with you. And the news was he was diagnosed with cancer. So the following days, whenever I used to be in the office, all of those days were spent in a hospital close to Frankfurt in Lich. And there I saw for the first time, I think I was 23, 24 at that point in time, I saw for the first time how hopelessness and helplessness affect not just the patient, but also the loved ones, the friends, and the family. You have to blindly trust that chef arts, that doctor who says, these are the therapies, I have spoken to the tumor board, I think this is what you need to do. You need to believe that the studies he's talking about are these studies meant for that patient, and that he knows it all. Nothing bad with that, but at that point in time, I asked this question very naively, why should we trust this guy? He can't know everything. It's the volume of data, of knowledge that's exploding in life science, and also the fact human beings ought to make wrong judgments at times. How can we get a second opinion? Who would be the second best guy in Germany? Or the best guy in Germany or in Europe whom we can take a second opinion from. So that's where we start the journey of Innoplexus. And then, of course, and I studied in a crazy tech campus of Indian Institute of Technology, Bombay. And as I landed in Germany with a scholarship, I found that Germany was a different country. So I start with this, the famous phrase, and people have written about it, the security mania, etc., the German apocalypse. So when you would ask people how they were doing, they would answer, not bad. And I thought, these guys are really depressed. Why would one be so negative? And it would become even more negative if you would be taking the first train from Stuttgart Hauptbahnhof to Düsseldorf at 4:51 in the morning. Apart from smelling the coffee and the cigarettes, the Nichtschlecht would be really even more negative if you were to ask. Over time, though, I realized when you would go to the US and say how you're doing, and they would say, perfect, fantastic. That fantastic was probably less honest than the German nicht schlecht. And I learned, understanding the context is really key. You have to normalize the context. The second small story to this, being in the university and being crazy and being hungry, as many of you are, that's why we all are here. I took 16 courses in the first semester because I just wanted to race through everything. I was then too not satisfied, and I would run around to professors saying I want to do something really cool. And the director of the program there advised that I meet a professor who was also a senior partner at one of my first employers, Professor Mikhail Chardin, who taught international taxation, because he's really bright and I would do something really cool with him. So I stand in front of his classroom. He's teaching a course. He comes out, he says, what do you want? And I literally told him, I want to do something really cool. He said, do you speak German? I said, no. Have you ever done anything with accounting, taxation? I said, never, ever. I'm an engineer. So he said, I have something cool for you, Deutsches Steuerrecht, German taxation. And the next day, I landed up in his office in Weilimdorf, close to Stuttgart, for an internship in German taxation. He had around 32 people in his team. The message to all of them in his team was, nobody will speak in English with this guy. He used to call me my Indian, mein Inder. Nobody was allowed to speak to me in English. And if I didn't understand something, I can ask back in English, but the response would always be in German. So that was the first rule. And the second rule was, we never waste time. So I was 10 minutes into the office, and one of his colleagues, he's called Hagen, he came to me with a Doppelbesteuerungsabkommen, double taxation agreement between Germany and China. He said, you need to sort out in German a problem with a permanent establishment that a German company might have in China, Betriebsstätte. I vividly remember Article 5 of that DBA. And I started my, my torturous journey learning German using leo.dict and killing myself through the German text literature, which was all in German, because the translations into English of that literature were even more difficult to understand than in the original German literature. Why I tell you this story is, I learned over time that it's a big lie that German tax advisors speak German. They have no clue of German as normal people speak. What they speak is tax German. They speak Steuerdeutsch. Even in normal course of conversations, sometimes the phraseologies they use is very, very tax German. In medicine, in intelligence services, in banking, any domain you look at, they would always use not natural languages, but a domain language. We call it a meta-ontology, but it's never natural language. And third, relevance is relative. So for different users, relevance would be different. And I use this this example of a meteor going to hit the planet Earth, and you have an American, a German, and an Indian guy, because you have to fire a rocket and destroy that meteor, else everybody else would die. The American is concerned about pressing the damn button. So his focus is output, getting the damn thing done. The German says, no, not that easy. It's not important that you press the damn button. Important is how you press the button, process orientation. And then there is this Indian guy who has just come from India. He says, I don't care about getting the damn button pressed or how this button is pressed. What is more important is who presses the button. So for the same problem, which is so critical to save our lives, different people coming in from different perspectives would define relevance as different. Of course, the how. So fundamentally, we understood it's about understanding relevance, normalizing context, and getting the ability to speak or understand the language of a domain. If you were to build a Google tomorrow, we knew in 2011 it has to be bottom up and not top down. It has to be vertical and not horizontal. In terms of building Innoplexus, there were 3 lessons. There are no shortcuts in AI. Learn the context. Now, there are different schools of thought in AI. 3 schools. The first school says computational power is everything. You get a big machine, and that machine can predict the prices of baby diapers, and the same machine can find the right drug candidates for a specific target in an indication. We don't subscribe to that school of thought. There is a second school of thought that says algorithms move the cheese. So we have the next best algorithm, we are stacking more neural nets, we are adding reinforcement learning, and we are trying to solve a really difficult problem, and we are able to solve it 2% better than everything else that's out there. We don't subscribe to that school of thought. And the third school of thought is, it's not about computational power or algorithms. What is important is, to whatever algorithms you have, you get the right relevant data fed in. Only then you would get context-aware insights. It's important to be able to extract relevant data, normalize this data, and feed it into algorithms for continuous analytics. So data moves the cheese. If you look at the data landscape, data is cheaper than water, but it's extremely expensive, because there are certain oligopolies that manually annotate this data and sell it because it's manually annotated with thousands of analysts at an extremely high premium out. So big pharmas can afford that. If you want to know the competitive landscape in oncology, you can pay a couple of $1 million. What about a small biotech company? Forget India or China, in the the Stolberger Valley close to Aachen. They cannot afford that. A Sloan Kettering and MD Anderson can afford that. What about a small hospital in Germany, in Singapore, in China, in India, in Eastern Europe? They cannot afford that. Eventually, a patient that's going to die, for that patient to know who are those key opinion leaders, who are those lighthouses in Europe, where are the right studies going on for me? These patients cannot afford to pay these data service companies. So data moves the cheese, and if we want to solve this problem, we need to find a way to automate this annotation process. And the third learning was buck stops at value. So you can solve the most complicated problems. It's always Pareto in life. The people who really want these problems to be solved, they should bite your problems, your solutions. So in the end, it's all about creating value for those big pharma companies, biotechs. It's about creating value for these hospitals and patients whom you are serving. They don't care about what algorithm you use. It's about precision and recall in the end. It's about how much do you save, the cost for them, and what impact in terms of coverage you have in the solutions you offer. So we started our journey in 2011, and as I said, what we did was we worked on a meta-ontology. So if you know about languages, children start with around 2,800 concepts and the semantic associations. And when you parse the brain of those children with storybooks, experiences, that ontology grows, that language grows, it becomes dynamic. And if it's an English-speaking child, it's around 500,000 words or concepts. If it's German, unfortunately, it's 5.6 million, if you were to know everything. So we started creating this meta-ontology, a meta-language that was a mix of different dialects and different sub-languages of life science, the SNOMEDs, the ICDs, the gene ontologies. And we started crawling, building a universal crawler that would crawl and extract terabytes of data and parse this ontology with these terabytes of data. We recently released a case study together with Google, and we demonstrated we can crawl 1 billion relevant pages a day. And I say relevant because it's not about what are the top hospitals in Germany. There is a guy sitting, searching what are the top hospitals, and then you are firing queries, or you are writing a Python crawling script to crawl the data from those hospitals. It's about scanning the top level domains to see what URLs are there and which URLs could be a hospital, could be a biotech company, could be a clinical registry, and so on and so forth. So we started crawling the entire life science digital universe, and then we got, using an ontology leveraged approach, all of this into a platform that we call Iplexus. And once you have all of this normalized data, you can do a lot of analytics on top. So I'll provide you some very basic examples. Because slides I've presented before when I was in consulting. So here is Iplexus. Now what you could do is you could search for anything. And you could see all the publications, the distribution of various indications in the entire scientific publication space. You could look at different trials. You could look at scientific congresses. We cover around 4,000 scientific congresses today. There's experimental data that's in there. If you want to look at any specific drug, you can see the entire landscape, the history of the drug, the regulatory history, the mechanisms, what has been published, what kind of trials have been done, the trial landscape. You could look at combinations and so on and so forth. And then, of course, there are specific dashboards. If you want to see what's happening in a specific setting, you could look at patient forums. It's social listening, but social listening in life science is different. It's not natural language, because if you talk of a migraine, many patients do not know that they have migraine. So the phraseologies or the ontology of migraine is really complicated. So you build those ontologies, you normalize all the synonyms, the homonyms, and you also know what is driving the share of voice and the sentiment in a specific case. So you could see what patients are actually talking about and things like that. Now, as I said, we have also built some use cases. So I talked about who are the lighthouses. Imagine we look at oncology, breast cancer, and we want to look at everything in terms of publications, who has published, who does trials, who does congresses, who is in HTA bodies, advisory groups, SAGs, DACs, and so on. And in Germany, I want to see who are the top people. And I can define the top people the way I want. I can give weightages. And I see Frau Dr. Habeck is the top KOL. I can see how she is the top KOL. I could see what is she doing in terms of research activity. I could see what has she published, what trials, what congresses. I could look at her network in different countries. And I can also look at how she connects with the top diffusers globally in the breast cancer space. And you define diffusers as nodes with higher diffusion centrality. You could also look at top brokers. Similarly, we have applications wherein you could do meta-analysis of trials. You could look at the preclinical landscape. You could build in disease models on top and kind of triangulate what you get from the trial registries and what you get from patient data. So here you see in terms of the top diffusing nodes globally in breast cancer space, if you have network layers of co-authorship trials, etc., with whom Dr. Habeck is connected to. So this is just one example. A couple of examples of some of the applications, but what I want to show here is once you have got the platform right, you can have scale and scope and building continuous analytic applications on top. Now, surprise, surprise, the same approach also works in financial services. So we have just released a product which is you have everything in German about German companies, Kapitalgesellschaften, the shareholders, the board members, the supervisory board members, normalized all the news feeds, all the litigation data in one place without manual intervention. And then, of course, you can build a KYC application, you can do an AML application on top, etc. And one more thing, and it's pretty important because the press release has come out today. What I showed you in life science, it's all about published data. So everything that's published, that's available in the digital universe. But there is a lot of data which is not published. What about the failed experiments? What about the published data, the data related to successful experiments that relate to successful publications? It all sits in the institutes, in the research institutes and universities. And why do professors, academics do not share that? Because they want to publish first. It's their data. Why would others want it? Because they would like to know what has not worked for others. It's a real option for yourself, even though it's a failed experiment for somebody. It could be that the hypothesis that you are trying to validate using the data, the experimental data, somebody might have completely different hypothesis and they might want to add your data to the data that they have and combine both the data sets to create a larger training data. So what we have done is we have added a stack that combines blockchain and some of the other technologies, and we have just filed around 12 patent applications in drug discovery and preclinical space. Any researcher in a research institute can extract the metadata, and that metadata is rendered searchable on Iplexus. The original data sits in the institute. It never leaves the institute. Only when somebody wants that data, requests, there is a transaction happening which is immutably registered, the block as well. So the IP remains safe, the original data never moves, yet there is more transparency on data related to failed and successful experiments that others might choose to buy. In the end, it's all about patience, because that's where the why is the beginning of any journey. And we believe with these different steps in that direction, we would eventually contribute to a world wherein people would share data that really moves the cheese. People would have access to insights, context-aware insights. And in the end, if you save 18 to 24 months, or 5 months, or 6 months, it's a patient that's waiting in the end to get the right medicine or the right therapy out. We are supporting and we are working on an event, hosting an event together with Frankfurt School on 18th of June. And the idea there would also be to get the people who started with a why and have some real practical solutions to problems in life science, financial services, and other sectors to hopefully give you an impulse to move in a similar direction. Thank you so much.